So good morning and welcome on the last summer series webinar focusing on concrete. We will talk about best practice for designing of prestressed beam. Let me introduce. I'm Lucas and I'm a product engineer for company IDEA StatiCa. We are using GoToWebinar platform. So on the right side of your screen will appear a control panel where you can type in your questions, and I will try to answer it after webinar or during the webinar. Just briefly to the content, all will be turning around the creating of the beam or geometry loads in IDEA StatiCa Beam, and we will prepare all the stuff for export to Detail. It's the goal. So I will turn off my camera, and at first I would like to introduce something. I would like to tell something about the geometry. The total length of the beam is approximately 24 meters. The height in the middle of the beam is 1.4 meters, and the beam is composed by the 6 openings with the diameter 0.3 meters. And it will be a pretangent beam where will be set, let's say, 3 rows of the tendons, and some of the tendons will be, let's say, separated, or they will have some blanketed length. So let's jump to the application IDEA StatiCa. So I will run IDEA StatiCa application and open Beam. At first, we have to create a new project and select what type of the beam will be modeled. So we will model prefabricated concrete beam. It will be prestressed, precast beam with the option of subsequent post-tensioning. It will be single beam, single span beam, and the beam and also the supports will be related to the bottom surface. So at the wizard, as the second tab, we have to set what type of the loads will be considered in the model. We can consider straight beam loaded in the vertical plane, or if you will have some loads which will be out of plane, or you will use straight or polygonal beam loaded in the 3D. So I will come back to presentation because it's the first really important note that if you export the beam to the detail, what's our case, so the total length will be set inside the application, not in the wizard. And if you're working only with the beam, and you would like to make a check only in the application beam, you can set the total length immediately in the wizard. So I can let 23 meters. Just step up to the settings of the design code, Eurocode, national annex will be checked. Design working life for this type of the beam is 80 years, and at first I create the cross section and at the middle of the span. So from our library, you can select some types. I will select advanced, and it will be an I shape with hinged flanges. So let me put in the dimensions. I only type the name. It's middle of the beam, and I prepared the parameters. So 570. I will create the cross section. And I can let the strength of the concrete C50/60. Okay, everything is prepared, and we will consider self-weight according to cross-section. That's all. No permanent load, no variable load. It will be set inside the application. Construction stages, really important part. At first, I would like to pre-stress the structure at 5 day, at storage yard 5.1 day, and the distance of the supports from the left and the right edge will be shifted about 4.56 meters to the middle of the beam. In the same way, for transport, it will be 25 day, final supports 35, superimposed dead load 60, and end of design working life is 80 years. Automatically, it's set it. So I create a geometry, and you can see what happened. I have a prismatic beam, and I would like to have some saddle beam. So we can jump to cross sections in the navigator and create a new cross section. I will use a copy operation, and I renamed the name which is in the middle of the beam. It's edge beam or edge part, let's say, and put the dimensions. So I only change the height of the beam. It will be 1 meter high of the beam. Copy the operation. Some imposed part. And I totally change the geometry. So give me a second. I will set the parameters. And we can continue. Okay, now I have prepared all the sections, and we can move to members. This is the reason why I said that the final geometry will be set inside the application. So the first part, the reason is the correct putting of the supports to the relevant places on the beam for the export to the detail. So I only change the type of the cross section. It's number 3. In the same way, the middle part will be 23.35 meter. I copy the members and change the length. So at the middle of the beam will be some saddle. So I create some haunches which will be symmetrical, and the length from the node number 3 to the middle of the beam is 11.675. Sorry, it's the number 3. Number 3 is symmetrical. I change the cross section in the beginning and change the length to the 1.675. You can see what happened. I created a saddle beam with the correct type, of with the correct type of the cross sections. So I will proceed to supports, switch off the member numbers, and I would like have only a hinge support by the point number 2. So I remove this support, and I remove also the supports at the point 6. So I have prepared geometry. I'm not sure, is something wrong here. 14. Okay, here none. Now everything is clear, everything is fine. So the geometry is prepared, and we can proceed to the load cases. So at first I will reopen the presentation, and I tell something about the loads, with some limitations, some restrictions. So at first, for this type of the beam, you can set or are set normally the point loads or uniform loads, some typical loads for this type of the beam, and the processing. So from the point of view of the point loads, beam, if we are inside the application beam, there is no limitations, because we are working on the 1D model. But after export, you have to keep in mind that you are going to transform the 1D member to 2D. So in the 2D can appear some local concrete crushing due to the concentrated load. So we have to handle with this in some specific way. For uniform loads, no restrictions for 1D and the 2D model. Everything is fine. Some other type of the loads, like deformation loads, rheology, temperature, and the settlement are neglected in the application detail. So please keep it in your mind that this internal force or these loads are neglected, are not exported to the detail. We consider TDA analysis for a beam, so we receive some rheology effect, some internal forces from the rheology due to the prestressing. The temperature, we can't put it directly, but we can use some user-defined forces from the third-party softwares. And we can also put some settlement, which is not relevant for this type of the single span beam. It's mainly for continuous beam. So yeah, I will jump to the project and create the loads. I would like to put the point forces to stage number 5. It's a final supports. So I click on it, go to the point forces, create a new load case. I switch on the number or member numbers and change it here. Number 3, put 100 kilonewton, and I will redistribute all the forces to the in this way. Okay, this is it's permanent load. I will come back to the load cases, create a new load case, which will be variable. I have to change the type. Just click on it and go to the variable load groups. The load groups aren't normally defined, like aren't automatically defined according, let's say, some type, that it's snow, it's wind. It's neglected here. You have to do it on your own. You have to do it manually. So all the coefficients ought to be defined manually. So I can let it for the purpose of the modeling of the beam and loading of the beam. I can let this prescription. So come back to the load cases and change to LG2 exclusive. Okay, go to the point forces, create a new point forces. I will change the member, number 3, 20 kilonewton. It's a point forces. and the redistribution will be in the same way as for the permanent, in this way. So okay, so we have loads from the point of view of the self weight, some permanent, some variable loads, and now what is missing pre-stressing. So I will jump to the presentation, and what we have to being aware due to the pre-stressing. We consider some pre-tangent and post-tangent beams or tendons in our application, but what you have to be aware that the unbonded tendons are not supported and can't be checked and can't be modeled in the application. So what is really important, I forgot, that there can appear that some tendons during the modeling will be out of the tendons due to the change of the cross section. So if you would like to consider the tendons in the calculation, during the calculation, so you have to switch on don't exclude tendons, and it will be considered during the calculation. The software automatically warn you that the tendons are out of the section, and you have to keep the rules that you have to switch on this checkbox. So I will jump to application and go to the tendon design module. So the tendon module is starting, and yeah, we are in. Okay, I will go immediately to the tendon design, tendon layout, and you have an option how to define the tendons. You can use a pretangent on the edge or pretangent in the line. So two different way for putting the tendons, but these are mainly straight tendons. So you can use some pretangent on the edge. You can see what happened. Automatically is detected to some edge, and you only change the number of the tendons, and you put the blanketed length at the end and at the beginning of the beam. I don't want to do that in this way. I delete that, and I will use some template or some import. So I have it here. It's according to drawing, which was shown before. So you can see that some type of the tendons are out of the sections. So we have to turn on the checkbox for calculation of the TDA. So at first, I would like to change the materials of the tendons because there is different. So I create from our library, select Y17 with the diameter 15.7 or 0.3, sorry, and I have to change it for all the tendons. And also the initial stress will be 1280 megapascal. I copy that to all tendons, and okay, I have defined the tendons, and just we can have a look on how it's the tendons are laid out in the cross sections. Okay, and I can go to the force design. The force design, it's a tool which will help you to find out if the tendons are if the tendons or if the stress on the beam is in some range according to code. So at first I will run the TDA analysis. Run TDA analysis, it takes some times, and what I have received, yeah, this is the standard equation for calculation of the linear elastic stress in the tendons, where we consider some normal force from the tendons area and the bending moments from the tendons, and also from the loads. So we receive some this type of envelope. So the calculation was performed, and at first we have to go to the result class, where are automatically predefined two let's say combinations. First one is for self-weight and pre-stressing, and the last one end of the design working life with this prescription. Okay, I will run the analysis, and for some seconds I obtain the results and the envelope of the stress on the concrete in the concrete, or yeah, in the concrete, and I can turn on and turn off the fibers, like the up or down, or top or the bottom fibers. This is only the envelope with the maximum value minus 11.3 for compression and 2.1 for tension. It means that the cross section will not be cracked. So we can jump immediately to the tendon stress or losses, and we can see the, let's say, the losses along the tendon. Yeah, so I can select the type of the tendons, or some yeah, the type with some blanketed length or without. And in the bottom part are important information about the losses, some encouraged loss, or some stress after short-term losses, and also long-term losses at the end of design working life. Okay, that's it for pre-stressing. Everything is prepared for creating the combinations. So I will go to the combinations and go to the edit, to the load combinations manager. I have to, all the combinations are automatically created, but the software doesn't know where put the variable loads, so it's up to you. So I would like to put the variable loads to the stage number 6, to all combinations for ultimate limit state and for service limit state. Okay, I just drag and drop. Okay, and everything is prepared for a combinations or for combinator. But there is another option. If you have some special combinations and you don't want to combine it or to use our combinator, you can use it your own combinations, some user-defined combinations. You use a plus button. You can select what type of combinations would you like to have. You change it for, like, evaluation will be linear, and you change the prescription, like here will be factor 1.4, let's say. It's only example. But what is really important, this combination, it's not sorted to or it's not fitted to any combinations. So I have to go to the construction stages. I will select, let's say, at the end of the design working life, go to the combinations, and here is my desired combination. I have to put it here. Now everything is fine. I will do the update of the combinations, go to the combinations back, and this combination is relevant for construction stage number 7. I just delete that because I would like to use our combinator, and what is really important is the settings. At first, end of the curing, so it means I will put 3 days. It means that it's finish time. It's a finish time of the curing, so some shrinkage is has been starting from this day. Okay, and here's really important: don't exclude the tendons from the calculation. Now I will run the analysis. Some warning will appear. You can see that the tendons are outside of the cross sections, but are considered in the calculation. Okay, I can proceed. I can start the calculation, the running TDA analysis again, and calculation the creep and the shrinkage on the structure and all the internal forces, reactions, deformations, like standard finite element analysis for 1D members. So I can come back to the presentations, and later on we will talk about the lateral stability in the application beam. To wait on the results. Okay, we obtain the results, some internal forces, and you can select some type of the cross section, some type of the construction stages. Let's say end of the design working life, and I can select, let's say, rheology. You can see what happened. It's the rheology effect at the end of design working life from the point of view internal forces. So I will go to the data tab and select what type of the calculation or the code check will be considered. I switch off the detailing, and I don't want to calculation the deflections, but I would like to check the lateral stability because it's important for this type of the structure. So at first we will go to the reinforcement, and we will reinforce the whole beam. But at first I have to cut the beam to some zones. I will select the zone, and I will create a section. At first, the sections will be related to the point number 3, and the position will be reference number 2. Here are reference points. So the distance is 0.8 for check the shear. I will copy that, change to the point number 3, and change the position 11.67. Okay, everything is fine. I have two, let's say, check 2 positions for code check. I only check the combinations, everything is fine, and I can proceed to the reinforcement of the cross sections. Due to the fact that we have a cross section from our library, the IDEA automatically provide some reinforcement template. I will use it. I will put 4 bars, 4 upper bars with the diameter 16, 4 lower bars with the diameter 20, 2 bars along the height of the cross sections with diameter 10, and the stirrups distance will be 0.15. Okay, everything is fine. Let's say these 2 zones are reinforced, and I will continue to the zone, to the middle zone. All the settings is set, and I can change only the distance of the stirrups on the 0.25. Okay, it's prepared. and I can go to the detailed checks. Now we will do the check for 1D mem or 1D code checks, and we have to find out if the beam has fulfilled all the checks according to code. You can see everything is fine. Everything is fine with the maximum value for stress limitations. We can check it to the stress limitation. You can see that the maximum value 16.2 megapascals. We are in the range. So I can close it and go to the lateral stability. We consider for code check of the lateral stability some let's say two regulations according to code. The first one is some transient analysis. At first I will put the value for code check from the point of view of the transient analysis according to some equations imposed in the code. So B is the width of the compression flange, 0.5, the height in the middle of the beam, 1.4, and L0T is the distance between the torsional constraints, so 23.35 meters. I copy that, change to the persistent, and you can see what happened. Now the status is not fulfilled all, or the situation is let's say over the limit. So what we can do if you obtain this, let's say this type or this mode for lateral stability, it doesn't mean that the beam will be buckled or will be or lost some stability, or if the beam lose the stability. It means that you would like to use, or you ought to use some higher type of the analysis, like let's say some buckling analysis with some alpha factor for check if the beam will be stable or not. Okay, what I have forgot, a creep coefficient. If we will, in the detail application, we work with some efficient modulus, so some effective modulus. So we need some creep coefficient from the TDA analysis. So you can find it here. You will go to the reinforcement, to the detailed. I will come back to it really quickly. Go to the calculation control, check on the stiffness, and run the analysis. And in the stiffness step, I obtain at the end of design working life, I obtain the creep coefficient 1.73, which will be put it to the detail app later on. So okay, everything is fine, everything works. Now it's time to the export to IDEA StatiCa Detail. So I will come back to the presentation and show you what options do we have. We have option to export only a part of the structure. I'm talking about the left part of the window. You can export only some part. Well, let's say will appear some big opening or some the other discontinuities, or you can export the whole beam. I would like to recommend to export the whole beam due to the fact that we have 6 openings inside the beam in the web. So the more benefit is to make a whole analysis on the whole on the whole beam. From the point of view of the export of the load cases or the load combinations, you have the choice. You can export the load cases and create the combinations inside the detail application, or you can export all the created combinations which were done by the combinator used in IDEA StatiCa Beam. I think here is higher benefit in this is compatible with the beam combinations, and after rearranging or redesign, it's automatically during the export created again, and you can work. It's a workless for you to create another combinations in the application detail when the combinations have been created in the application beam. So I will do the process of the export. So in the ribbon, I will export the detail. I will select the path where to save it. Okay. I would like to export the whole beam, and what is really important, to select the construction stage. I would like to export the combinations. It's recommended to export the whole combinations, but for the purpose of the demonstration, I would like to export only one for ULS, and sorry, the critical one for ULS, one for which will be characteristic, and one which will be a quasi-permanent. So I export it. Okay, now we're starting the application, and all the geometry is being in the process of export, and you can see what happened. You can check the geometry. Due to the fact that we have created the correct or precise geometry in the beam, all the supports are correctly put it to the places, and what we can do, we can put only the openings. So I will use a plus button, create an opening. The opening will be a rectangle. The diameter will be 0.3 meters. It will be related to the master member M1. I can turn on the names. Master point M1 is the first one. Here is the master point. I will measure it from this point. So the X position is 4.55. Z position 0.48. I only copy that. The distance between the openings will be 1.5 meters, so 5.95. Copy that, only 7.35. I will copy the operation again, change the master point to 6, and put the negative sign 4.55 minus 5.95. Copy minus 7.35. Everything is prepared from the point of view of the geometry. I can check it again. Okay, everything is fine, and I can proceed to the loads, because this is the most important part of the modeling. The modeling is to check and to know how it works after the export. So I will come back to the presentation. So the combinations in the details the loads are derived from the internal forces which were created in the application beam. So you can see this is some uniform loads. This is from the self weight. here some point loss is a permanent, and here is a variable. Is derived from the bending moments and the shear forces in the application in the application beam. So I can come back to the detail. So it's here, yeah, in the detail, and you can see I have some warning on the left side. Distributed point load is not connected by its full length to the specific edge. What does it mean? I can check some, let's say, permanent load case, and here is a variable load case. All the permanent loads are imposed to the one load case, and the variable also, because we are working with the loads, not with the internal forces due to the nonlinear analysis. So I can go to the load cases, to the permanent load cases, load impulses, and here is some yellow highlight. It means that the point forces is and the radius and the effective radius where the point forces are redistributed over the effective radius to the concrete. It's the simulation of some distribution of the loads to the concrete, and with this, let's say, type of the effective radius, you avoid some local crushing of the concrete. It's really important to set it according to your real let's say structure. So I mean, let's say that here will be some secondary beam which will be imposed on this main pretangent beam. So you will use some width of the effective radius, simulate the width of the web, let's say. So, and this description means that it's connected with two members. So it's not the full length, or the redistribution area is not on the full length of the one part, but for both parts. So it's only the warning. Everything is fine, everything works. Okay. So I can jump to the reinforcement, and I will use a template which has been prepared for this purpose. So I will create it. I will use it. You can see it happened. I will use a 3D reinforcement. What you have to keep in mind that we don't cover the detailing. The detailing is up to you. You can put what type of the reinforcement on, or the amount of the reinforcement what you want, but we don't keep it. This is the reinforcement. So everything is prepared for analysis. So I will go to the check and click on the analysis. To speed up the calculation, I have pre-calculated this example. After analysis, you obtain the results for ULS and SLS. Yeah, the results for the ULS and SLS, and also the summary. And in the summary, you receive some information. What was the entity? Which entity was the most utilized? Let's say for ULS, it's the strength of the reinforcement, and for serviceability limit states, it's the stress limitations. It's a critical check 7.2. So we can check it deeply in the detailed checks. So I will go through the strength of the concrete, where we give you some insight to the maximum values, and you can see that the maximum values is around the opening. Around the opening is the stress concentration. The stress concentration, if I will come back to the presentation, the stress concentration, you can see here is some peak, but in the ULS code check, or in the ULS diagram, we have some plastic branch. So here will be some it's getting the stress concentration will be redistributed around the opening. So I will come back to detail and show you more results. So the maximum value is compared to the design value, and how I mentioned, the maximal stress is on the rebars, but not on the longitudinal rebars, but you can see around the opening where is the concentration of the stress on the stirrups mainly. Okay, so now let's jump to the stress, to the serviceability limit state, mainly to the stress limitations, where you can see the stress redistribution, where here is a maximal value due to the fact that we are using a linear diagram for serviceability limit state, and we can check long term and the short term effect on the concrete. You can see from the point of view of long-term effect, the stress is lower around the opening, and for a short-term effect, where it's not considered the creep coefficient, which I have forgotten to put it here, sorry, but I will show you where to put it. So I will come back to my previous example, and in the material models, in the part of the concrete, here is a creep coefficient. So you put here 1.73 and sorry 1.73, and it will be considered in the calculation. I have it here in the pre-calculated model. So let's have a look on the crack width. We have I was trying to model this beam to any cracks for quasi-permanence wouldn't appear in the middle part of the beam, and I hope it was passed for a code check of for the 1D code checks in the application beam. And you can saw that also on the linear stress along the along the length of the beam. So you can see that the maximum crack is not in the middle. Any cracks will appear here, but around the openings where is the stress concentration, and there will appear some cracks. So the processing works correctly, and the final code check is a nonlinear deflection, where you can see some short-term deflection, some long-term deflection with the effect of the creep, and some total deflection with consideration of the variable loads. I think that's all. I won't show the bill of the material and the report because I think it's not relevant, and I would like to summarize and make some summary of some points to the modeling of the beam, the saddle beam, or some different type of the beam with the openings for export to the detail. So at first, the preparation of the precise geometry in the beam, it's really important to make it. You like a user have to select a construction stage which you would like to code check. You can change the supports in the application detail, because we have some, let's say, some optional supports for some type of the beam in the library, and you have to be aware of the local crushing in the concrete if you're using some point loads. Rheology effect is neglected after export to the detail. The detailing is not checked up, and creep coefficients should be taken over from the RCS application or from the beam to the export to the detail, and put it precisely to the detail. So yeah, some Q&As. I think we don't have enough time, so I will answer your questions after the webinar and send it via email. Please wait after webinar. Please fill in forms, some short survey. The recording will be delivered till the 3 days on our web page or on our YouTube channel. And if you are a new user or you would like to try it, how it works, how IDEA StatiCa works, please reach out on our trial. And for all tutorials and the materials for let's say concrete or steel, please visit our website, the support center part. I think that's all from my side. Thank you, and enjoy the rest of the day. So bye bye.